Hello and welcome to SciLux, the podcast where we talk about scientific developments and technological changes in Luxembourg. And in today's episode, last one of the season, we are talking to Eric Buttini. Eric Buttini is the head of the Department of Geoastrophysics at the National Museum of Natural History in Luxembourg, and we are actually meeting at the museum, so I would love to tell all the listeners about all the fascinating things Eric has here in the office. And coming back to him, he has discovered, together with his collaborator Matt Dawson, several asteroids. Eric often shows his work to the general public, and he is the National Outreach Coordinator of the International Astronomical Union. Thank you very much for coming today, Eric.
Thank you. Hello.
I have to say that when I was preparing here, I was thinking, for me, astrophysics is basically the highest mountain I can think of when it comes to science. It's a really difficult subject because it makes us feel very small. Do you think about it on a daily basis or not?
Yeah, definitely. Every time when I look in the sky and I look at the stars, I'm thinking about that. It's also what it makes it difficult sometimes to explain it to the general public because one have to take abstraction of a lot of things and one have to project oneself in another dimension, I will say. And that makes it very challenging to explain to people, but it's also what is fascinating on this subject.
Yes, for sure. Because when we look at models, right, they are just these small things. Sometimes they are not even to scale. So we can't really imagine how vast the space
is.
Exactly.
So even explaining the scale and then realize how big this whole thing is. The first introduction actually I made when I'm doing explanation about astronomy. And so just explaining what are the scales and where we are and so on. And that makes it fascinating.
Yes, for sure. For sure. I have to say that one of the tests I ever failed at school was about distances between planets and the sizes. Because it was, it's difficult to remember all this for sure. And it was not really taught, in any way in reference to something.
I have to admit that I can't remember all the distances. And I always have to look at by myself on a sheet of paper when I'm talking about distances because I'm also not very good in remembering numbers. And so
it makes me feel very much better right now. So it's not only me, I can admit it then. But what I mentioned in the introduction is that you are actually both a geophysicist and an astrophysicist. What are you closer to if you think about your study or research?
Yeah, in my daily work, I'm doing a lot more of astronomy and astrophysics because I'm the only one in the museum dealing with that subject. On the other hand, in geophysics, I'm the head of a team of researchers based in Valferdange, where we have a mine with geophysical instruments recording seismicity of the whole world. And there are 4 scientists who are making research. Okay, I'm leading this group, but they work by themselves, and I have to not to intervene as they are doing in research. And my daily work is more in the field of astronomy and outreach activities in astronomy.
And you're alone with all this.
I'm in the museum as the only one.
So this coming back to this discussion we had in the very beginning, that it's so vast and so mind-boggling, and then you're alone to explain it to the whole world.
I always say I'm the only person paid for doing astronomy in Luxembourg, because you have no research in astronomy, you have no other institution who's dealing with astronomy. So I always say I'm the only person dealing with astronomy in Luxembourg, paid for it. But actually, we have also now the Science Center in Differdange who also do some astronomy work, outreach activity. So I'm a little bit exaggerating, but...
Exactly. Actually, one of our previous guests recently was Olivier Parisot from LUCID.
Yeah.
So it's not necessarily he's doing astronomy. It's just part of the machine learning work that he has, right? That is part of LUCID, but it's true they don't have astronomy per se or astrophysics at least. So it's a different story for sure. Okay, so you said outreach. One of the things that you do is the mobile planetarium. So I think in different places people might have seen this interesting black tent, I would call it, that appears at events. And what is it actually? What can we see there?
The problem is that we have no real big planetarium in Luxembourg, and we were in discussion for years talking with politics to one time have a real planetarium in Luxembourg, but actually we don't have one yet. And about 20 years ago, I just decided to buy a mobile planetarium for the museum. So it's, as you say, this is some kind of black tent, black igloo, and I can blow it up with a ventilator, and people can enter it and then have the same experience as in a normal planetarium. They sit on the floor, and in the middle I have a projector with a fisheye lens, and I have a computer simulating the night sky, and then I can explain everything on astronomy what I want to do. It's like normal planetarium. The only thing it's mobile, so I can go to schools, I can go to festivals, and that's what I'm doing a lot of my time. Yeah.
So there's no, come visit us somewhere, right? But you actually go to people.
Exactly. Very often go to schools when they have some kind of project about science week or so on. Then I'm asked to come, and then I go with.
What's the capacity? How many people can get in?
Get up to 25. Yeah, 25 person can go in. So when I'm in school, I'm normally there for a week, and I take all the classes from all the levels of schools they have, and so I'm there for a week.
It must be very tiring after that.
Yeah, well, I'm not alone. I have a colleague who is helping me also on this show. So.
And what do you talk about? What do you choose? Is it like different subjects every year, or do you have some flagship?
No, normally I can explain what I want, but I've just realized that to do some normal introduction to observing the night sky is sufficient. So I'm explaining some constellation, how to recognize the easiest constellation we can see. So Big Dipper or Orion, and then I'm explaining how to find the brightest star, how to find the northern star, polar star, how to find Sirius, and so on. And then this is normally the first part. The second part, make some explanation about the solar system, about the planets. So in the planetarium with a projection, one can travel to the planets and see how they look like, and give explanation about how big they are and what the atmosphere is, and so on. And it's an introduction in astronomy. And I could do also subject about galaxies, about black holes, but I've noticed that people need what they want to know is an introduction, and also maybe what they learn in the planetarium. Then they go out in the night and try to recognize what they have learned in planetarium. And I've realized that it's sufficient for the general public to do that.
And we have to say that actually they can't always go out and see things. Yeah. I can see behind you there is actually a poster about an initiative about dark sky, exactly, right? And the light pollution. So maybe even with the planetarium, it's easier to show things to people, isn't it?
Exactly. Well, I have in the planetarium, we have always good weather. So you have no clouds, no rain. So I can show everything and independent on what the weather is.
And now is the time for the pub quiz question. As usual, remember that the answer to this question is only at the end of the podcast.
Okay, I want to know which is the brightest star we can see in our night sky.
Okay, and I have to say it's a tricky question, so watch out with the answer and don't Google. I always say that. Listen until the end of the podcast where we reveal it. So how is it at schools here in Luxembourg? Is there astronomy, basics of astronomy, or not at all?
No, nothing.
There is a lot to do on your site as well, for sure. And there's a lot to do also on the side of the museum. We are meeting today for a particular reason as well, because there is a very special exhibition coming to the museum. So it's called Asteroid Mission, and it's going to be here soon. So please mark it up in your agendas. Tell us, what will we be able to see?
Well, it is a project that I had in mind always for several years. You may know that about 5 years ago, Luxembourg decided to push in the direction of space resources. And most of the people don't really know what this is all about. And I thought, well, it would be nice to have an exhibition about this subject, about asteroids in general. And so I submitted it to my director, and I had a go. And so I started to work on that exhibition. And now it opens on the 10th of November. Actually, it has 3 main subjects. First is the meaning of the beginning of the formation of solar system. So what do asteroids tell us about the story of the solar system? The second subject is planetary defense, because we know that, well, Earth had already been impacted by asteroids, and were very big. Talk about extinctions of dinosaurs. And, we know that the threat is there. So we know that one time we will probably discover an asteroid which will collide with the Earth in about 20, 40 or 50 years from the discovery. And then we have to think about, okay, what can we do to protect the Earth? And that's also treated in the exhibition. So the different techniques that are studied to protect the Earth from asteroid impact. And the third, as I said at the beginning, is everything, the third subject is everything about asteroid resources, space resources. What can asteroids bring to the Earth, or differently, what can we get from asteroids and then help us here on Earth?
And develop in space as well, right? Because we need to remember
exactly.
also that we have this tendency of Earth-centric thinking, right? But space resources are very much also about going further into deep
exactly.
space.
It's the thing is that the first thing it's in mind for the scientists now for asteroid research is actually getting water to use it as fuel to travel further in space. So that's the first thing. That's what people actually don't know when we talk about asteroid space resources. They think about rare metals, gold or whatever, but that's not for the moment, absolutely not the point. The point is looking for water. Also on the moon surface, looking for water. For example, establishing in the moon bases, you need water for living there. You need water for construction. You need water for everything, actually. And that's the first element that is now in mind for when we talk about space resources.
Yes, and figuring out where and how to extract it and everything else,
and that's
right?
what we are trying to explain in this exhibition.
Okay, so I'm very excited. I'm pretty sure I will go more than once, just like I did with the Lost Ocean exhibition. I think I was there 2 or 3 times. So here I'm probably going to be there. You'll see me discovering, because this is definitely something that interests me. And I wanted also to take the opportunity to say that we are meeting, of course, because we wanted to discuss the next exhibition, Asteroid Mission. But I also wanted to tell our listeners that I'll be at the museum on the 14th of October because of the museum night. And it's a bit related, very much related actually to what we're discussing today, because I'll be telling the people, the visitors, twice during a short guided visit about the moon and the exploration of moon and the Apollo missions and exactly what Luxembourg did, how we got the flags back that are there at the museum, but also what we're going to do next. Because as you said, Luxembourg and space resources, that's a very, very important topic. There's a lot going on. And also our listeners could already notice that we discussed it at least 2 or 3 times, if I'm not mistaken. We've had Catherine Hadler from ESRIC to talk about space resources. Yes, 3 times. We had also the space resources startup program. And we also had a discussion about space law. So we had already a few different things, exactly because Luxembourg is the right place to discuss it. There is a lot going on, as you mentioned.
That's also treated in the exhibition, space law, space ethics.
You probably can't wait. Does it mean that you're now ready for the launch, or there's still a lot going on?
Absolutely not ready, but we still have 6 or 7 weeks, I think. And now, for the moment, the content is finished. For the moment, most of the work is done by our team of museographic and scenery team. They are just designing. They're designing the exhibition, which like your resume here.
Please remember, if you can repeat once again, it launches, I think, when the Science Festival is there as well.
It launches together with the Science Festival. The meet and greet for the Science Festival and the opening of the exhibition is on the 10th of November.
And if you're listening to it later, don't worry, because it's going to be there for quite some time. So it's very, very possible that you're listening to the podcast and the exhibition is still there, right?
Exactly, because it lasts until the 18th of August 2024.
We leave the exhibition, we come back to your research, because we said, okay, you go to people, you tell them a little bit about night sky, but you also observe the sky yourself, right? There is the LUCID project, isn't there?
Exactly. Well, I'm not observing myself. There's a colleague of mine, which a scientific collaborator. His name is Matt Dawson. He's actually a musician and then semi-professional. I always say he tells himself as amateur astronomer, but it's quite semi-professional, and he has built a telescope by himself with material from the recycle center. Only the mirror of the telescope, that is professional mirror, but other material, he just collected it as a recycling center and built a telescope by himself. And he's doing that about 20 years now, observing asteroids. And I've been in contact with him a long time, and then we decided to make a project together. So he's a little bit financed by the museum, and he's doing the observation. Well, I'm treating the data.
Was it through that project that you observed the geyser on a comet?
Exactly. That is some kind of participating science. So it's from the Minor Planet Center, United States. They have projects where people, amateurs, can participate. So they call out of an observation and they said, well, this object or this comet or this asteroid is now actual or has to be observed more closely. And then the amateurs over the world who want to participate can observe and then send their observations to this center, and they are treating the data. And that was that comet. I don't remember the name actually.
I can tell you because I have it written here. It's 29P Schwarzmann-Wachmann, I think. Yes, there you go.
So that was a call out of this Minor Planet Center. You can observe this comet because it has a particular behavior. And because we call it an outburst, say it's like a geyser on a comet. And this one has actually very often such outbursts. And it is not really understood why. And so it has been called out for the amateurs to observe this comet, and actually Matt Dawson was the first one who observed a new outburst of this comet and then sent it to the center, and the data have been treated. And so it's a little discovery to better understand this comet and the behavior of this comet, actually.
But it's also very interesting because I have to personally say that I had no idea that this was possible on a comet. Because, of course, I have this common thinking. You have, something glowing and then the tail, right?
Yeah.
But you said this is special only for that comet, or it can happen?
No, actually, it's known that comets have outbursts. Only this one has very often, and that is not really understood why. And to understand it, you have to observe. And then, as normally in research in science, you make models and try to look if your models gives the same as observation, gives the same result as observation. And it's a small part of participating in this observation.
It's interesting you said you want to understand, because I wanted to exactly move to something that is terribly difficult to understand, at least for me, all the challenges of astrophysics. So we are leaving, let's say the typical general public discussion, and we're moving on to the big questions of astrophysics, right? So when you get questions from your public, or when you are just thinking about your research and in general, what is the most challenging for you in astrophysics right now?
I have to admit that when I get questions from other persons, I normally also have to look and to read about the subject. But because you have so many subjects in this field of research, so many different things. Actually, I'm now more in the whole theme of asteroids. So if I got a question about black holes, I also have to look in my books and read it again. And then, okay, as I have a study of physics, it's easier for me to understand what is written there. And then I try to simplify it and then to explain it to the general public. So that's actually for me why it is also difficult, because I do not know everything about astrophysics, actually. And for the last 10, 12 years, I've really only worked on the domain of asteroids, also for the exhibition. So it's easier for me to answer and give the explanation. But if I got another question, I also have to look about resources.
But you're pretty used to the fact that people ask you about black holes, for example, right?
Yeah.
So what do you say? Because I've read and heard so many different explanations. What are black holes, actually? What, in your words?
Black holes are regions in the universe where the material is so dense that nothing escapes. So we know that we have gravitational attraction on Earth because of the mass of the Earth. And then if you imagine that you have some million suns together in the shape of 1 millimeter, that you can imagine that the gravitational attraction is infinitely high. So that's this gravitational attraction makes it that nothing escapes, and also the light does not escape, and that's a black hole.
But that makes it tricky also to observe, doesn't it?
Yeah, you can't observe it directly. You observe it because of gravitational effects that black hole has on the immediate surrounding.
And it also comes when it comes to observing, as I said, when asteroids you can see, but what dark matter, neither, right? It's not something we know it's there.
So now we are on the point of dark matter. Well, I'm not really know what to say now. So if you had a question about dark matter, I would have to go to my literature or to look on different internet sites and again to read again. Okay, how can I explain as dark matter to someone who has absolutely no formation in physics or astrophysics?
But I love this answer, because this is very, very important. We need to remember that, first of all, we kind of treat the scientists very much, we're scratching the surface, but it's sometimes very complicated matters that not only you need to understand, but you also need to be able to use very, very simple language in order that we understand. So if you now give me all the jargon, I will not get it. So there's no point, right?
That's part of my job, actually. And you mentioned at the beginning, I'm also the national outreach coordinator of the International Astronomical Union. And that's actually what my main job is. Trying to use the simplest words to make people understand what it's all about astronomy and astrophysics. That's my main job here in the museum.
So we will steer away from dark matter, dark energy, anything else. I will not make you feel more uncomfortable here. And let's come back to the asteroids. So I'm pretty sure when you start talking about asteroids, people say, oh, when will we be hit? Tell us.
Actually, we don't know. Well, Earth is permanently hit by dust or by small asteroids, or we call it meteorites. And it depends on the size of the object, if it's totally burned in the atmosphere or if it reaches the ground. And actually, small meteorites don't make any damage, so that's not really important. And for the moment, they try to study or to find every asteroid more than 100 meters in size, because if they fall on the ground, they make damages on local areas. And of course, if you go to kilometers wide, you can have damages on regional or even continental range. And we know that the very big one, as the one who destroyed most of the life on Earth 66 million years ago and also make dinosaurs disappear, such an event only occurs once every 100 million years. So that's not the problem. But what is important is to have sky surveys and detect all the smaller ones. We can have damages on regional or local or even on continental range, so that is important. And there, of course, the smaller ones occur, I say every 50 years or 100 years, and the bigger one, its recurrence period it's longer.
And if I want to see an asteroid, can I see one at the museum or not?
You will see in the exhibition parts of asteroids that are meteorites, because it's only in a matter of definition. We call asteroids or asteroids objects that is orbiting the sun, which is not a planet or moon, or moon is not orbiting the sun, but or comets. So asteroids are actually remainings of the formation of the solar system. And when an asteroid or the part of an asteroid enters the atmosphere and falls on the ground, we call it meteorites, but actually it's the same. And we will have meteorites, of course, in the exhibition, and the different types of them, stony one, mixed one, iron meteorites.
That's great. You explained that. So now we will all know not to say that again. But it's also important what you said about the composition, right? Because let's leave the planetary defense apart and be a bit more positive in the sense of what we can find on an asteroid. Because first of all, not people, because it was not a human mission, but we managed to land on some, right? And examine these.
Exactly. And that's what is interesting now, because we are now making the interview today. But yesterday, there was a successful sample return of an asteroid. So it's really something exceptional because it's very challenging to plan such a mission, and also that the mission is succeeding. It was the NASA, they sent it in a spacecraft to an asteroid millions of kilometers away from here. They touched down on the asteroid, collected samples and got the samples back. And actually the module in which the samples landed yesterday in the late afternoon in USA, and that's very exceptional. It's only the third time that samples from an asteroid have been collected successfully. They think they have about 250 grams of it, so that's also very much. And they will be sent to laboratories all around the world, and then the samples will be analyzed. And actually, one theory is that the ingredients for life that appear on Earth have been brought to us by asteroids or by comets. So that will probably be analyzed to look what materials are in these samples. And because these materials are really the very first elements just even before the formation of the planets. Well, we know that the solar system have been formed out of a great cloud of dust and gas. And in the asteroids, we still have the primordial elements of this cloud. And then you can really look what was there just at the beginning of the formation of the solar system. And that's very exciting.
It's really like answering the big question of life.
Exactly. Well, this is one of the theories. Also, other theories about the appearance of life. And this is one of the theories. That these ingredients have been brought to Earth by asteroids and comets.
So hopefully we'll meet again, and then you'll tell us what they discovered, right?
Yeah. Or maybe you come, because we have, for the exhibition, we also have a program with lectures and conferences, and we have we have invited, I hope he will come, one of the world specialists of this theme. It's Patrick Michel from the Observatory in France. And he's often here in Luxembourg for Asteroid Day every year, and we have asked him to come for the exhibition, also to make a conference. And maybe if now he's coming at the end of the exhibition, he will have the first results of this sample analysis.
Okay, very, very interesting. I have a feeling that we, again, as I always say, just scratched the surface. But yeah, now looking at the clock, I think this is the moment that we go back to the pub quiz question. So if you can remind our listeners what the question was about, and then please give us the answer.
Okay, I want to know which is the brightest star we can see in our night sky.
And the answer is?
Well, the answer is Sirius. It's the brightest star. It's a star we can actually only see during wintertime. You can see it in summertime, but Sirius is part of the constellation of the Big Dog.
And not the Northern Star?
No, it's not the Northern Star. Northern Star has another particular thing. It's the only star that does not change its position in the night sky. It's too complicated to explain on radio or on an interview. We have to show it in the planetarium what is particular of Northern Star. But Northern Star is not the brightest star. Sirius is it.
Okay, and this is a perfect teaser. Remember, go next time you see the mobile planetarium, so you'll have the explanation. You can ask the question, and if you ask the pub quiz question there, you'll know the answer already, right? For sure. But yes, what remains for now is definitely just remind you once again, go see the exhibition that is coming or is already there, depending once again when you're listening. Come for the museum night, visit all the museums, but spend a lot of time at the Museum of Natural History, because it's not only me, it sounded like that, but there'll be a lot of other things happening, right, during the museum night that you prepared. So there'll be some concert, I think, as well, and some other things.
In the museum night, we have actually talked about my colleague, Matt Dawson, who's discovered the asteroid and also the outburst, the geyser on the Comet. And as I said previously, Matt Dawson is also a musician. And so he will give a concert at the night of the museum. So it will be the asteroid hunter, Matt Dawson, will give a concert.
Okay, and then you can ask him also how you built a telescope from recycled parts.
Recycled parts, yeah.
That's definitely also very, very interesting. Okay, thank you very much for coming today, Eric. It was really a pleasure to talk to you.
You're welcome. Thank you.
And this is it for today. Don't forget to subscribe, to follow us, to listen to us, and to discuss everything you have to discuss. Come visit us at the museum or just meet me anywhere else. I'm always present at the science events here in Luxembourg. This was SciLux, and my name is Hanna Siemaszko.